line which touches the circle at only one point is called tangent of a circle. Secant of a circle means a line which intersects the circle in two different points is called secant of a circle. అంటే వృత్తాన్ని ఒకే ఒక బిందువు వద్ద స్పృశించే రేఖను ఏమంటామంటే స్పర్శ రేఖ అంటాం. వృత్తాన్ని రెండు వేరు వేరు బిందువుల వద్ద ఖండించే రేఖను ఏమంటారంటే ఛేదన రేఖ అంటాం. ఓకే, నౌ let us observe that. And one important theorem that we have discussed yesterday, that is, this is very important theorem. What is that? Here is the tangent which touches the circle at one point, that is P. Now let us draw a radius at the point of contact. Observe here. Let us observe here. So this is the radius which it is drawn at the point of contact, and we know that this radius always makes 90 degrees angle with the tangent at the point of contact. Radius always perpendicular to the tangent at the point of contact. At the point of contact. So radius is always perpendicular to the tangent at the point of, and tangent to radius ని ఎక్కడైతే టచ్ చేస్తుందో ఆ పాయింట్ దగ్గర if you find the angle between these two, then that will be equals to 90 degrees. Here OP is always perpendicular to XY, or we can write in another way, angle OPY, angle OPX, which will be is equals to 90 degrees, and this is another important theorem, that is. Okay, next, based on this theorem we have discussed one more important point, that is finding the length of the tangent. Let us observe, children, here. So here is a circle with center, this center. Now there is a point, external point, which I have taken. So this is the external point which I have taken. Yes, so from this external point I am going to draw the tangent. Let us observe that. Here is this is the tangent which touches this circle at this particular point. Let us assume that this is the external point is A and this point is B. Here AB is the tangent. Now what is the length of the tangent? That is, to this, suppose if you know the distance from the center, that is, so, and if you know the radius here, sorry, here this is the center O, and this is the distance D, and this is the radius. And now if we want to calculate the tangent length, that is AB, which can be used by making use of the Pythagoras theorem, square root of, that is hypotenuse square, which it is OA square minus OB square. OA is distance, D square, minus this is R square. So length of tangent formula will be equal to length of tangent, which it is equal to square root of D square minus R square. So this is the length of the tangent, square root of D square minus R square. So if D is the distance of the external point from the center and R is the radius of the circle, then the length of the tangent, which will be equals to square root of D square minus R square. And another important point is radius always makes 90 degrees with the tangent at the point of contact. Okay, yes. Now let us these are the key points which we have discussed yesterday in the starting of the yesterday's lesson, that is. Now let us observe that. Draw a circle and two lines parallel to the given line such that one is a tangent and the other is a secant to the circle. Here is a small rough sketch, it is asked to draw that. So draw a circle and two lines parallel to the given line such that one is a tangent. First of all, let us here one line is drawn. This is, let us observe that. Now there is a circle which it is drawn. Let us observe, this is the center of the circle, and this is the circle. Now draw a circle and two lines we have to draw parallel to a given line. Actually this is the given line I am going to name it as L. Let us assume that this is the given line. Observe children here carefully. This is the given line. Now we have to draw two more lines such that the two lines should be parallel to the given line. To this line they should be parallel, and one should be a tangent, one should be a secant. If it is a tangent and it has to touch the circle at only one point, so this line I am going to name it as AB. And now what I want to do is I want to draw a parallel line. We can able to draw the parallel using the set square. You know that set square use chesi parallel line draw cheyochu. Suppose if here I want to draw and that it should touch the circle at only one point. Oka point daggare touch cheyali. So let us observe children. Now here I am going to show that is how to draw the parallel here. Let us observe that this is the line which it is moved parallelly, and this is the line it is shifted to here, which it touches the circle at only one point C. Now let us assume that this is P and this is Q. Now new line name it is. Now this is drawn parallel to this only, exactly, but it touches the circle at only one point. Now this is considered as the tangent, and not only that, and it is asked to draw one more line. This is a rough sketch only, no problem at all. You can, so if you want to draw fair sketch, that is you can make use of set square to draw the parallel line. Okay children, now PQ is the parallel line which it is parallel to AB and it touches the circle at point C. That means only one point, therefore it is considered as a tangent. Now it is asked to draw one more parallel line to the same line AB. And AB ki inkoka line parallel ga draw cheyamanaru, but it should intersect the circle in two distinct points. Observe children here also. So this is again I have drawn a parallel line. Now this line which it intersects the given circle and two different points. Suppose some D comma E, let us assume that this is the point, and this I am going to name it RS, or you can write same DE also. Why? Because if you know the 2 points we can able to name. So if you observe, these three lines are parallel to each other here. So AB is parallel to PQ, which is parallel to RS, and all the three are. And here with respect to this, L is a line, but PQ touches the circle at only one point. Therefore this is called tangent of a circle. And whereas RS, if you can observe, RS intersect the circle in two distinct points, therefore which we can call it as a, yes, which we can call it as a secant. This is called secant. So this is the secant and this is the tangent, and which these two lines are parallel to the given line. So this is the draw a circle and two lines parallel to the given line such that one is a tangent and another one is a secant to a circle. Oh, I think it is clear children. Okay, now let us move to the next question. Here is, calculate the length of the tangent from a point 15 centimeters away from the center of the circle of radius 9 centimeters. It is again simple. So like the previous question, that means here it is asked to calculate the tangent length. But I will show the diagram. You can complete the calculation part and give the answer children. Okay. First let us observe the diagram. Let us draw one circle. Here is that. So this is the center of the circle. With this center I have drawn a circle. Let us observe that. I have considered an external point, some point. So this is the center of the circle. It is naming is not given. Therefore this is O and this is P I am going to assume. Now this is how many centimeters away from that? 15 centimeters away from the center of the circle of radius 9. Now it is asked to find the length of the tangent. Let us draw a tangent here. Let us observe that. Tangent is the line which touches the circle at only one point, that is. So this is the point where it touches PT. Let us assume that. Now join O and P, which the center to the point this is, and join OT, that is. So these two. So here let us observe that here. Let us observe this point where it is. So this is perpendicular. So this is the radius, and what is the radius of the circle which it is given? Yes, it is given that 9 centimeters, and the distance from the point to that, this is 15 centimeters. Now let us try to calculate PT. So we know that. So distance D we know that, and R we know that. Length of the tangent PT will be. So can you give the answer children? Harita, yes, absolutely correct amma. That is next Saradha. Okay. Length of the tangent, yes. Remaining children also please try to go calculate that and try to give the answer. Yes, please respond for the children. Yes, Sivalingeshwar Rao, yes, well done. Okay, Saiti is Pramod, Venkataharsha, yes, good. Yes, very good. Harsha, Dhanalakshmi, yes, Reshma, good. Ramana, yes, all they have given. This is as usual, we know the direct. So the given values are distance from the center first. Distance from the center, which it is equal to d is equals to 15 centimeters, and the radius is also given, r is equals to 9 centimeters. So now the length of tangent is equal to square root of d square minus r square, which will be is equal to rate of d square, which it is equal to 15 square minus 9 square. So 15 square, which will be equal to 225 minus 9 square, it is equal to 81. Let us subtract that. 5 minus 1 equal to 4. 22 minus 8, which it is equals to 14. So square root of 144. As we know that the square root of 144 is 12. So 12 centimeters. Therefore, length of tangent is equals to 12 centimeters. That is. So here the distance d is given as 15 centimeters and the radius is given as 9 centimeter. It is asked to find the length of the tangent, which it is pt, which it is equal to 12 centimeters. Okay children? Yes. Okay. This is a simple question and direct question. Now next question. Prove that the tangents to a circle at the endpoints of the diameter are parallel. And this is another important question for 2 marks children. So this is a 2 marks important question, please. This is. Yes. So now prove that the tangents to a circle at the endpoints of the diameter are parallel. So to a circle at the endpoints of the diameter are parallel. Now let us draw the first diagram relevant to this. This is the center of the circle and this is the circle. Yes. So tangents to a circle at the endpoints of the diameter. I have considered a diameter. Diameter means it is the longest chord passes through the center of the circle. Let us observe that. So this is the center of the circle. Observe children. So this is the center of the circle and this center of the circle is O, and the endpoints of the diameter are, I am going to assume it as one is A and another one is B. Observe that. These are the two endpoints. Now at the point A, one tangent is drawn. At the point B, also one tangent is drawn. That means these are the point of contact and sprusinche bindu. Let us observe that. Let us draw a tangent at that particular point. Okay children, let us observe that. So here is the tangent which touches that, and here is also the tangent. Now I am going to name this tangent as xy and this as pq something. We can name it as anything, your wish, that is. Now the proof is these two lines must and should parallel. అంటే ఈ రెండు లైన్లు ఒకదానికి ఒకటి ఏ విధంగా ఉంటాయని మనం నిరూపణ చేయాలంటే దే మస్ట్ బి ప్యారలల్ టు ఈచ్ అదర్. ఓకే, ఎప్పుడైనా సరే ఎండ్ పాయింట్స్ దగ్గర, అంటే దట్ టు డయామీటర్ యొక్క ఎండ్ పాయింట్ దగ్గర, విత్ దీస్ యాజ్ పాయింట్స్, ఇఫ్ యూ డ్రా ద టాంజెంట్స్ then they must be parallel to each other. Okay, yes. Observe children here. Now what is given in the question? Let us write down what is actually given. O is the center of the circle. O, center of the circle. O is the center of the circle, and next one is AB is diameter. AB is diameter. AB is the diameter. Okay, yes. Now observe this. This is complete. Now what is to be proved? RTP, required to prove. అంటే నిరూపణ చేయాల్సింది ఏంటి? We have to prove that these two are parallel lines. That means that XY is parallel to PQ. XY is parallel to PQ. XY line is always parallel to PQ line. That is. Now I am going to prove directly. Proof, that is. Here construction is not essential. Let us observe children. The first thing, I am going to use is first theorem 9.1. What is 9.1 theorem? 9.1 says radius is always perpendicular to the tangent at the point of contact. Here A and B are the point of contacts. So OA and OB are the radii. So as per the known theorem, what does it say? Radius perpendicular to tangent at point of contact. సో దిస్ ఇస్ అంటే వ్యాసార్థం అనేది స్పృశించే బిందువు వద్ద స్పర్శ రేఖతో 90 డిగ్రీలు కోణం చేస్తుంది. సో దిస్ మేక్స్ 90 degrees and this also makes 90 degrees. Since OB is radius and OA is also radius, OA వ్యాసార్థం అవుతుంది, OB కూడా వ్యాసార్థమే అవుతుంది. సో since radius is perpendicular to the tangent at the point of contact, that means angle OAY is equals to 90 degrees. Why? Because radius. Similarly angle OBQ is also 90 degrees. Let us observe. This I am going to assume it as 1 and this as 2. So OAY is 90 degrees and OBQ is OBQ is also 90 degrees. Now what I am doing is I am going to add these two. Angle OAY plus angle OBQ, upon adding that 90 plus 90, what will be the value? Which will be equals to 180. So these two angles, if you observe, these are the two angles which lies. If you observe, diameter is only one line only, and this diameter is touching the given two lines at two distinct points. Now x with respect to xy comma PQ, AB is transversal. The diameter is called the transversal. If this is transversal, interior angles on the same side of the transversal is 180. Since from this angle OAY plus angle OBQ is equal to 1. So sum of interior angles on the same side of the transversal, interior angles of one side of transversal is 180. Interior angles of one side of transversal are supplementary or 180. If they are supplementary, then according to the known theorem, what you can say is if those two lines must be parallel. So XY is definitely parallel to PQ. So whenever the interior angles on one side of the transversal is 180, no doubt at all those two lines must be parallel. If they are parallel, interior angles on one side of the transversal will be 90. Why these two 180? Means this angle is 90 and this angle is 90. Now the sum of these two is 180. Whenever the interior angle sum of one side of the transversal, if it is 180, no doubt at all those two lines must be parallel lines. Alternate interior angles are equal. Okay, alternate interior angles are equal. That is also can be used. Why? Because here this angle 90, if we can assume, and this side angle 90, then these two are alternate interior angles are used, and in that way also we can able to prove. No doubt at all. But this is also better. So no doubt at why? Because this side angle is 90 and this side angle is also 90. Alternate interior angles are also equal. Therefore, no doubt at all. So absolutely your answer is also correct. So once again, so to a circle there is a diameter AB. At the endpoints of the diameter, if you draw the lines, tangents, then those two tangents must be parallel. So the given one is O is the center of the circle. So O is the center of the circle and AB is the diameter. XY is parallel to PQ. Now as per the known theorem, radius is perpendicular to the tangent at the point of contact. Angle OAY is equals to 90 degrees. Angle OBQ is equals to 90 degrees. Angle OAY plus angle OBQ is equal to 90 plus 90, which will be equals to 180. So therefore interior angles on the same side of the transversal, since it is 180, therefore the given two lines are parallel to each other. Okay children? Yes. So that is another important point, that is, so this is okay. So this is all about the first exercise children. So in the first exercise mainly the concentration is all about the mainly that is radius is perpendicular to the tangent, that idea, and how to calculate the length of the tangent by making use of the formula root of d square minus r square. So and the next one is, yes, so this is the main concept, another main concept, that is what, tangents to a circle at the endpoints of the diameter are always parallel. Okay, so based on this, that we have completed the first exercise. Now we will move to the another concept, that is, so number of tangents to a circle from any point. And this point actually yesterday also we have discussed, and again it is given. So once again please try to learn the concept, that is, yes, okay, yes children. So here is the number of tangents to a circle from any point. So let us draw a circle here. Here is, this is the center of the circle, and this is one circle. Not center of the circle, somewhere else, an interior one point it is drawn, this is, and this is the circle. Now the first case I am going to take this one. So this is the case 1. Observe children, this is the case 1. So what is that? Tangents, number of tangents to a circle from any point. Now the point which I have taken is the interior point, that is, so the point which is exactly inside of the circle. Now let us observe that how many tangents that can be possible to draw. Now for example, if you want to draw a line passing through A, let us draw the line first. So this is one line. So if you observe this line, since the point is inside, now it is touching the circle at 2 different points. If it touches the circle in 2 different points, can it be called as a tangent? Yes, no doubt at all, it is not a tangent. If the line intersects the circle in 2 distinct points, then it is called the secant. Not only that, let us draw one more line. Let us observe that. Again, it intersects the circle in 2 different points only. This is this point and this. Now also we can call it as secant. Now let us draw one. Even if you draw any number of lines which passing through the particular point, is it children? Now all these are not tangent, they are called the secants. Now how many tangents that we can able to draw? If you consider a point which is inside of the circle, then means from that point if you draw any line, it will not be a tangent, it is a secant. Now from a point inside the circle, no tangent can be drawn to a circle. Observe children, అంటే ఏదైనా ఒక పాయింట్ తీసుకున్నాం అనుకోండి ఇన్సైడ్, ఆ పాయింట్ నుంచి మనం కానీ లైన్స్ డ్రా చేస్తే అది సర్కిల్ని ఎన్ని పాయింట్ దగ్గర ఇంటర్సెక్ట్ చేస్తుందంటే 2 different పాయింట్స్ దగ్గర ఇంటర్సెక్ట్ చేస్తుంది. సో ఇఫ్ ఇట్ ఈస్ ఇంటర్సెక్టింగ్ ఎట్ 2 different పాయింట్స్, దేర్ ఫోర్ ఇట్ ఈస్ నాట్ కన్సిడర్డ్ యాజ్ ఎ tangent. Therefore from inside to a circle, how many tangents we can draw means, if the question is asked, yes, you have to give the answer that 0 tangent. Why? Because each and every line is a secant. అంటే ఒక వృత్తము యొక్క అంతరంలో ఒక బిందువు తీసుకొని ఆ బిందువు నుంచి వృత్తంకి ఎన్ని స్పర్శరేఖలు గీయొచ్చు అని అంటే, ఆ వృత్తం యొక్క అంతరంలో బిందువు ఉండడం వల్ల ఆ బిందువు గుండా పోయేటట్టు కానీ రేఖను కానీ గీస్తే ఆ రేఖ వృత్తాన్ని 2 వేరు బిందువుల వద్ద ఖండిస్తుంది. ఇట్ ఇంటర్సెక్ట్ ద సర్కిల్ ఇన్ 2 distinct points. If the line intersects the circle in 2 distinct points, then it is considered as a secant, not the tangent. Therefore no tangent can be drawn. So the number of tangents will be equals to, yes, it is equals to 0, the first one. Now I am going to consider the second case. Okay children, that is, so what is the second case? Let us observe here. Yes, here is the circle. Now let us observe that here I am going to take the second case, that is different. Yes, this is case 2. What is the case means? Now I am going to take a point which it is on the circle. Now at this particular point, if you can take, this is the point P. Now it is tangent. Let us consider somewhere else. Now here it, if we can draw, now this is the point Q. Again it is possible to take, draw a tangent. Next, here at this particular point, again this is, let us assume that R. Now let us consider some other point, that is, yes. So this point I named it as S. That means that if you consider, suppose this point, again it is possible to draw one tangent here. Now the second case is, if the point is on the circle, then at each and every point on the circle, there can be possible to draw a tangent to the circle. Therefore, now how many tangents to a circle possible by taking the point on the circle? అంటే సర్కిల్ మీద ఉన్న బిందువు నుంచి బిందువు దగ్గర tangent గీయాలంటే there are infinitely many points on the circle. At each and every point, it is possible to draw a tangent at that particular point, so that the number of tangents that can be drawn to a circle by taking a point on the circle is infinite. అంటే వృత్తం మీద ఉన్న బిందువు, ఏదైనా బిందువు వద్ద వృత్తానికి స్పర్శరేఖలు గీస్తే అలాంటి ఎన్ని స్పర్శరేఖలు నిర్మించవచ్చు అంటే వృత్తం మీద అనంతమైన బిందువులు ఉంటాయి కాబట్టి ప్రతి బిందువు వద్ద ఒక స్పర్శరేఖని గీయొచ్చు. therefore infinitely point. So if the point is taken on the circle, yes, so if the point is inside the circle, then no tangent. If the point is on the circle, then it is possible to draw infinitely many tangents to a circle. Okay children, if there are infinitely many tangents which can be drawn to a circle by taking the point. So if it is interior point, no tangents, 0 tangent. If you take a point on the circle, infinitely many. Now if you take a point exterior of that one, that will be the case 3. Okay children, now I am going to consider the case 3. That is the, so one point is which it is interior, and one point which it is exterior, and one point on the circle. So these two cases completed. Now the third case, let us observe here. So this is the circle. Now there is a point which is outside of the circle I have considered. This is the point. Let us name it as this point as something A. Now from this point I am going to draw the tangents to the circle. This side one tangent can be possible, and this side also. So from this particular point, if you run, so this I am going to name it as AB, and this is his. AB and AC are the two tangents which can be drawn. So from a point which is exterior of the circle, from a point which is exterior of the circle, then two tangents can be drawn. అంటే ఎన్ని tangents draw చేయొచ్చు అంటే రెండు. So here number of tangents to a circle, this is important concept, not problems. From this we may not get any problem, but bits. So if you consider a point which is inside of the circle, no tangent can be drawn. Why? Because all are secants. If you take the points on the circle, at each and every point it can be possible to draw a tangent. Therefore infinitely many points exist, therefore infinitely many tangents can be drawn. Now case 3, if we consider a point which is in the exterior region, from that point if you are going to draw the tangents to the circle, then how many tangents can be possible to draw? Yes, no doubt at all, it is possible to draw 2 tangents. That is, so if it is interior, no tangents, exterior 2 tangents, on the circle if you take any point, so for each and every point it is possible to draw a tangent, therefore infinitely many tangents. Okay children, I hope it is clear. And even my phone is also not working today to observe the chattings and all, sorry. So that's it. Okay, now so one more important theorem we have: the lengths of the tangents drawn from the external point to a circle are equal. Okay, so the lengths of the tangents drawn from the here now itself from an external point, if you draw the tangents అంటే ఒక బాహ్య బిందువు నుంచి వృత్తానికి స్పర్శరేఖలు గీస్తే how many tangents can be drawn? No doubt at all, it is possible to draw two tangents. So the two tangents lengths are definitely equal. The two tangents lengths are definitely equal. So that is to be proved. Let us observe here. So for this, let us draw a relevant diagram first. This is the center of the circle and this is the circle. Let us observe that. So I am going to consider a external point. This is the point. So here this is the center of the circle. I am going to name it as the center of the circle as O, and this is the point, external point P. This is now from P to the circle. It is possible to draw two tangents. Let us complete the two tangents. This is one tangent and this is another tangent. Okay, yes. Now let us assume that this tangent is PA and 1. Now let us draw the radius also here. This is, and this is the line drawn from the center to the point, and this is one radius and this is another radius. Now where it is intersecting the circle, that point, this I am going to assume it as A and this I am going to assume it as B. Let us. Okay children, so here the lengths of the tangents means PA and PB. Now the lengths of the tangents drawn from an external point to the circle are equal. అంటే external point నుంచి circle కి డ్రా చేసేటటువంటి tangents lengths రెండు కూడా ఈక్వల్ గా ఉంటాయని ప్రూవ్ చేయాలి. సో దిస్ ఇస్ ద థియరం. ఇఫ్ యూ ఆర్ గోయింగ్ టు ప్రూవ్ ఎ థియరం, ద కామన్ స్టెప్స్ ఆర్ సేమ్: గివెన్ డేటా, రిక్వైర్డ్ టు ప్రూవ్ డేటా, and any construction if you have done that construction, and the proof. Okay children, now let us write the steps here. The first, let us try to write the given data first. What is given in the question first? O is the center of the circle and P is the external point. O, center of circle, P, external point. PA comma PB are tangents from external point. From external point. So this PA and PB are the tangents from the external point. Now RTP, required to prove. What is to be proved is, and very clear, the lengths of the tangents drawn from the external point are equal. So what are the two lengths of the tangents? One is PA and another one is PB. So PA must be equals to PB. Now construction. So what is the construction we have done is, so join OP and draw OA OB radius. Draw OA OB radius at that point. Now I am going to prove this one. Observe children. So to prove this one, I am going to use the congruency idea. And first thing what we are using is, here radius is always perpendicular to the tangent at the point of contact. This angle will be 90 degrees and this angle is also 90 degrees. First you can write the statement: radius is always perpendicular to tangent at the point of contact. Radius is perpendicular to the tangent at the point of, so angle OAP is equals to 90 degrees, angle OBP is also equals to 90 degrees. Let us assume it as 1. Now let us consider these two triangles. What are the two triangles? In triangle OAP comma triangle OBP, let us observe here. So if you observe these two triangles, the first one is OP is angle OAP is equals to angle OBP is equals to 90 degrees. These two angles are 90s. Observe children. Why? Because radius is perpendicular to the tangent at the. This is already from 1 also. Already 1 we have mentioned. And next one is and OP is equal to OP, which is common side. Common side is always equal. Why? Because OP is the side which is common for both the triangles. If it is a common side, always equal. And next one is radius in any circle will be equal. And similarly, OA is equals to OB. OA is equals to OB. Now right angle equal, hypotenuse equal, one side equal. So therefore, by RHS congruency, what you can say is triangle OAP is congruent to triangle OBP. Okay children, whenever these two are congruent, by CPCT means by corresponding parts of congruent triangles. Corresponding parts of congruent triangles are, why? Because here AP is correspondence to PB or BP. So this is, so therefore automatically the corresponding parts will also be equal. Therefore AP must be equals to BP or PA must be equals to PB. Anything we can say that. అంటే ఈ రెండు ఎప్పుడైతే కాంగ్రెంట్ అయ్యాయో మిగిలినవి. సో వన్స్ అగైన్, సో ఫ్రమ్ ద ఎక్స్టర్నల్ పాయింట్ ఇఫ్ యూ డ్రా ద టాంజెంట్స్ టు ద సర్కిల్, దట్ ఈస్, so those two tangents lengths are always equal. So we have to prove this theorem and it is very very important. And given O is the center of the circle, P is the external point and PA, PB are the tangents from the external point, and we have to prove PA equal to PB. What construction we did is joined. We have joined OP and OA, OB perpendiculars also drawn. That is not perpendiculars, we have radius are drawn. Radius. Now the first point is radius perpendicular to tangent at the point of contact. This is a known theorem. Then angle OAP is 90 degrees, angle OBP is also 90 degrees. Now I am going to consider the true triangles. So first angle OAP and OBP each is 90 degrees, that we know that, and OP is the common side, which it is common side. This is both, for both this is the side which is common, and OA equal to OB, which two are radii, both are radii. Radius are always equal, therefore right angle equal, hypotenuse equal, side equal. Therefore by RHS congruency, triangle OAP is congruent to triangle OBP. By CPCT, AP will be equals to BP. Therefore the lengths of the tangents from the external point are always equal. Okay children? Yes, this is the geometrical proof. Okay, so and this idea can be used in solving the problems, particularly in second axis. Main all problems are based on this idea only. From external point, tangents lengths are equal. So okay, now there is a small do this or activity is given. Try this activity is given. Let us observe children here. What is the try this actually? Use Pythagoras theorem and write proof of the above theorem. So whatever the theorem we have discussed, actually previously we have not used the Pythagoras theorem, we have used the geometrical proof, that is RHS congruency. Now the same question proof, by making use of Pythagoras theorem, it is asked to calculate. Okay, let us try it once. Okay, yes children, so let us once again, you draw the rough sketch, the sketch what we have drawn. This is the center of the circle and this is the circle and this is the external point, this is, and from this point two tangents are drawn, and this is the line joining center to that point, and these two are the radii. Yes children? Yes, let us name it as the same like the previous one only. So I am going to name this same as it is like that. So this is P, this is A, and this is B, and this is O. Okay children? Now, and we know that this is 90 degrees and the same. So as we know that, but the same radius is always perpendicular to the tangent at the point of contact. At the point of contact. Now angle OAP is how much then? Angle OAP is equals to 90 degrees. Now according to Pythagoras theorem, I am going to calculate AP. So according to Pythagoras theorem, I am going to calculate AP first. What is AP here? This is one of the side children. So one of the side will be equal to square root of hypotenuse square OP square minus OA square. This is okay. Now what I am going to do is this, I am going to simplify. This is OP again as OP only. Now OA I am going to replace with OB. Why? Because in a circle radii are always equal. Okay, so OA is equals to OB. Now this OA I am replacing with OB. Since OA is equal to OB is equal to radii, both are radius, that's why both will be equal. Now if you can observe in this triangle, OP is hypotenuse square minus this is side square whole root, which will be equal to PB or AP, BP or PB. This is why? Because in triangle OBP, angle B is equals to 90 according to Pythagoras theorem. So this, now very clearly AP must be is equal to BP or AP, PA is equal to PB. That is simply why? Because this triangle I have considered. First I have calculated AP length. AP is square root of OP square minus OP. OP square as it is I am mentioning the same, but OA just I replaced with OB. Since OA and OB are radii, they must be equal. Okay, so even if you use root of D square minus R square, the same formula. Why? Because this is D and this is R. So root D square minus R square is AP and root D square minus R square is again PB. So that is also, so whatever you are said, that is correct 100%. So even we can use, or else simply this step, two steps, OP square minus OB square, which it is in this triangle, which it is equal to PB. Therefore AP equal to PB. Therefore from the external point to the circle, the tangents lengths are equal. Okay, so previously we have completed by making use of the theorem, that is RHS congruency theoretical part. Now the same proof which we did by making use of the Pythagoras theorem. So I hope it is clear. Once again the statement is, from the external point to the circle, the two tangents can be possible to draw, and that two tangents lengths will be equal. Okay children? Yes. So today actually starting up that completely disturbance, and anyway we have completed some extent, and it is already 6:25 and difficult to start new topic, that is, and so that with this I want to close today's session, since the theorem is completed and application problems will be and constructions will be. So tomorrow I will explain. So with this today I am going to close, and we will meet children tomorrow evening at 5:30 p.m. Thank you.